How's it going, everyone? Welcome. I'm William Gonzalez. And let's take a look now at this chapter from this book known as Scope and Closures as a way to finally understand that and be able to describe what is this in the most succinct way possible. So, because thanks to Kyle Simpson, we went through describing is JavaScript. So the environment that is around as well as it is inner behaviors and mechanisms. So by looking first at the outer environment, right, to zoom out what JavaScript is and who makes that and why the name of JavaScript, as well as the uh, people who owns the legal trademark or the company that owns the legal trademark and who oversees this spec, which is the TC39 commit, what it does, how they do, what is their motto, and with the spy that we can run out these JavaScript engines based on these implementations in any different places, the client, the server, the light bulbs, or fridge and robots. The only reality that matters is the webs. And how now, despite this, there are some funny or uh, tragic events that happen in the community where now the TC39 they have to go back to the drawing table because they were about to break the web. And because of this mismatch between the reality of the web and what the spec or what these people that come from different web related companies that they of course are exposed to the reality of the web, but not all of them knows it is true state. So this is why, for example, Smushgate event is a good explanation or a good fact of what the things in this kind of events that can happen. And there is now a particular appendix that describe is those JavaScript engines that they don't want to follow this particular spec because of the reality of the web. And there is an appendix on the spec that says that. Also is the polyfill. What is a polyfill? As well as the JavaScript environment that we can run our code, particularly the browser console that is not a fully compliant ES, or it's not a fully compliant uh, JavaScript. It's just a friendly mode, and some of these observable behaviors that now uh, makes the case. So also the different programming approach, the inner mechanism of how now JavaScript process source text a into binary code, and the fact that based on this observable reality, we can now if essence, if not in practice, says that JavaScript is a compiled language, which is something that we're gonna describe that in this video with this chapter or from this book, the scope and closures. Also, we look at the concern around the JavaScript performance and how, for example, the group of engineering has showed that JavaScript is in fact a fast language. For example, by porting its now Unreal game engine into the browser and run at full 60 FPS, using now this subset of JavaScript known as uh, the the ASM, all right, that provides some hints to the JavaScript engines to do some optimizations. So years later, so now we have is this WebAssembly, which is like the spiritual successor, but in terms of, or instead of actually parsing and then executing the code, they skip that, and it becomes now this universal compiler target, right? And also, we went through the strict mode. Why do we care about this? Which is a mode in which um, tell developers how to write good code that has a good chance of optimizing and run, that have a good chance for the JavaScript engine of optimizing and running uh, the code, right? So this is just the outer broad stroke of the JavaScript. And then when we look now at the uh, inner mechanism in JavaScript, all right? First is like now how JavaScript processes files. What is a program, which is a standalone file, and how they can collaborate or act as a single one via the by sharing the states or through the linking process in ES6 models. Also, what is the most important fundamental features in any program, and that is, values. All right, what are the different type of value that we can have? String, number, and they each one of them follow a specific spec. All right. Also the boolean, the string, the symbols, the kind of emptiness, null and undefined, and the objects. And how now in objects we have arrays, object in itself, which is is a map, is a table, right? That has now is this one column with all the unique values, and the second column with all the possible values that it can have, and also functions. And what is the role of functions in the language? Okay, whether it's a procedure or a strict mathematical definition, what a function is. All right. So the other is that how can we now use these values in our programs as a literal and held inside of a container. So with that, uh, because we have different syntax forms on how can we hold those values in our programs, whether it's by using var, let, and cons, as well as other functions, syntax, other syntax forms as well, like functions definitions, as well as for of loops, all right, and in specifically with the functions, why the functions definitions like this is now uh, in analyzed by the language, right? So we have now functions definition and function expression, and what happens and what is the subtle difference between them. So function definition is something that is processed before the code it is executed, and this is when now the compiler, all right, is starting to create this map. It's not reserving space of memory for that. It's creating a map of all of these variables that you define inside of your functions, with the associated identifiers, or this is the resolution of variables, and it is reference. So this lead us to also how to work with variables when it comes to compare values, and what does it mean comparing values in JavaScript, which is this referential equality. Um, and it compares that by looking at the referential identity of each one of those values, and this is how it's going to compare, uh, which is a fancy way to say, hey, there are now unique values, pretty much like 42, the number 42 is unique to the number of the real numbers, all right, of the integer number, there is no 42. There is no 43. There is different way to represent those numbers, but the identity of this number, it is only one. And this is now based on this. And I can actually ask here Claude a little bit if I didn't lose my mind. Okay, so it is safe to say that based on the so based on, so it's safe to say that referential identity in JavaScript is the way of how to determine if two values are the same. So for example, there is no other 42 number, all right? However, there are several ways to represent that, but the value is itself. Referential identity is actually refers to whether two reference points to the same object in memory, not whether two values are conceptually the same. Okay, referential identity. This word because primitives are compared by value, not by reference. There is no referential identity involved here. JavaScript just check if the values are identical, but for objects, exactly. So if two values are identical, it doesn't mean that referential identity exactly, if two values are identical, doesn't mean that comparing a primitive doesn't mean that comparing primitive doesn't mean that comparing primitive is like comparing referentials for each value, since each values in the case of primitive are is an identity to itself. That's really an insightful observation. You're touching on subtle but important topic here. You're right that there is a philosophical parallel for primitive in JavaScript. Values identity is referential identity in a sense because the reference is to value itself, and the reference in object is a location in memory, right? So you're correct. The primitive comparison is essentially a referential identity, just as the value is. This is why some language distinguish between referential equality and structure equality. This distinction between referential equality and structure equality, the JavaScript primitive has inherent structural value identity. So if you're correct that primitive comparison is essentially referential identity, just as the value rather rather than a memory location level. It is a different type of referential identity, but conceptually similar. Does this refers to the same thing? This is why some languages distinguish between reference equality and structural equality, right? Referential equality and structural equality is based on its content. So referential equality is based on its identity, whereas structural equality is based on the content of its value. So referential equality is based on this identity, are the same thing, and the structural equality say, hey, does this have the same content? So for example here, and this is something that is especially useful to understand from this point, because it will now remove a lot of the mystery and cloudy that we can have in our minds, especially when we explore these operations that we can do with our values, right? So whether it's value comparison and value conversion, right? Also, we look at the way of how can we organize our code in functions. But I do think that it's quite important to recap this referential identity and structure, referential identity and structural equality, because both of them refers to the same conceptually. In other words, say, hey, if they are the same, if they have this, are these the same thing? So you don't compare is now paper. One you don't compare is, you can compare two different papers like this, right? But one of them is a tissue paper, and the other is now a receipt paper. The material is the same, but the purpose or what they represent are different. And this is now this philosophical aspect here, that the TLDR of this is to say, hey, we can now is, well, understand more about this. And this is something that even child can understand that, all right? Is there not the same thing? That's referential identity. And the other is a structural equality, which is, hey, are they the same? Does this have the same content, right? So in any case, also we look at the way of how can we organize our codes, whether it's by class, functions, or ECMAScript models. And now they're digging into the roots right now in 2025 here, which is, I do also think that ECMAScript 2019, which is the last addition to the collection here, is interesting. They don't mention, okay, the reflect object. Okay, why am I mentioning here? Hit a pause here, because and the proxy object. This is something, well, this is part of the exotic objects, okay, or objects that you can use here in the language. The reflection in control abstract operations. So this is now exploring at the control abstract operation is things like this. Okay, so now we're starting to connecting is this index collections, the array, I don't know why it doesn't open up. Don't be shy. Don't be shy. Don't be shy. Why this doesn't open up? Hey, this is not opening up. Okay, why not? Okay. It's like from that version, ECMAScript 2019. Okay. No, ECMAScript 2019. 2019. Here, ECMAScript version history in 2019. You should be able to exactly open up this one. Good, good. I do think that I was looking a different way, but here now digging into the roots is, for example, in things like this, the control abstract operations. Okay, something that we look is at the iteration itself, right? And protocols to now consume each chunks of data one at a time. Okay, using now this iterator protocol. And also is the iterables values that we can consume. There is also another, this is part of the control abstract operations. There is also another topic here that we didn't talk about because we just broadly speaking is the the JavaScript inner features, right? So for example, this control abstract operations like the iterator, the generator function, and the async, even this is also important here. Promise objects, okay, an async function object as well. So all of this is describing is this control abstract objects. When you look at this control abstraction objects, control abstraction object is to work with the, they don't actually mention or they don't go too much into this, which to me is quite lame. I mean, it's quite lame that they don't dig too much into this, or they don't describe that. It's an interface is set to property key whose associated value match specific specification. Any object that provide all the property are described by an interface specification confirms to that interface, and the iterable interface, a function that returns the iterator objects, the return object here, and the iterator, the iterable interface, and the iterator interface. The async iterable interface and the async iterator interface. A function that returns a promise for an iterator result object and the iterator result interface here. So why am I looking at this and describe this, despite that this is not part of this video? This is just go beyond a little bit on the of the topic, right? Especially is, let me take a look at this book. The getting star, the get star here. Okay, but this is for here. I'm more interested is on looking at this, the readme perhaps, exactly, and the object that is here. So it is interesting that we're not going to talk about the sync and async or the ES next beyond, but this sync and async that is part of this control abstract objects in is based on that. So now JavaScript not only provides these objects as values, interesting. So JavaScript provide now objects for control the code, for code. Unfortunately, they don't describe this, but they just say is control abstractions objects, right? And what are the role of these particular objects here, right? Unless you read about them, you know, unless you read the spec about this. A generator object is an instance of a generator function and conform to both an iterator and iterable interface. So generator interface directly inherit property from the object that is the value of the prototype property of the generator function that create the instance. So only by reading at this and generator abstract operations, generator star, which is something that happens behind the scenes. So only by reading is at this and what the things is doing behind the scenes is the way of how you can truly understand what these objects or these control abstractions objects are doing and they provide to you and why they are in there. So for example, with the iterations, we have now this ability to consume data one chunk at a time, implementing now the iterator interface in identifying a particularly collections of value if that is an iterable, if that implement that iterable interface. Similar when you talk about now generator functions like this, the generator functions objects are functions that are usually created by evaluating generation, generator declaration, generator expression, generator methods. They also may be created by calling the generator function, generator object relationship. So you can take a look at this, right? So the object of prototype, here you got now is the iterator. So when you now call this, it has now a prototype to the G1 prototype that points to the generator prototype, that generator prototype points to an iterator prototype that points to an object prototype that this actually now points to null, right? This is through the prototype. And on the instance, okay, each generator function has an associated prototype that does not have a constructor property. Hence, generator instance does not expose access to its generator function. Again, I don't want to confuse too much of this because this diagram can be quite wild to get it. But what I do want to at least illustrate here is that this digging into the root section, right? Where we are looking now is what is the how the field of JavaScript is, and understanding it is ebbs and flows, particularly here with this control abstraction operation, is just to determine that, right? It's just to say, hey, this is now our part of the JavaScript engines, or part of the spec that JavaScript engines must implement, and that is the iterator. And what is an iterator? As well as a generator, as well as a promise here, right? As well as a promise here. All of these are objects that now provide is just control mechanisms. I know that this might sound quite abstract. We're gonna see a couple examples later on how you can do that. But the problems they are solved, or the aims to solve, for example, is the iteration, is that how you have now this, imagine a spreadsheet with more than 100 million columns, all right, which is not weird, all right. For example, if you are the IRS, okay, or if you are the ARCA in Argentina, or any of this agency that needs to keep track of all of this taxpayer, all right, your records, the amount of record is huge, is huge, all right. We're talking about millions. So if we have now millions of records, how can we now is uh, get those values one chunk at a time, because the memory is limited. We cannot load all of those values in there. You can think of this like you have a lot of different um, if you have now so think of it like if you have now several baskets where you throw your several laundry basket, okay, Monday, Tuesday, and so on and so forth, right? So in order for you to know is which one of those baskets you want to do the laundry next, well, and I know that might sound like quite extreme. Let me put a more concrete example here of organizing stuff. Okay, so in order for you to now, once you install multiple applications, and all of these applications are are spread across your device, right? So you have is for the banking, for the fitness, for foods, for um, booking, reservations, and so on and so forth. Tax app, or the IRS apps. If you want to pay your taxes from your app, so if you have, and also social media networks. So if you have all of these different networks here, all of these different apps, and not, I mentioned just only five, but we know that each one of those might have is two or three or four of them. So the point of this is that if we want to now make our life much more easy to access each one of those information, all right, so wouldn't it be better to group them so we can now is consume them much more easy. We can have access to that. So this is the idea behind of this huge amount of collections, all right, huge amount of records, all of them like in a spreadsheet, and then you want is to now query uh, chunk by chunk, okay. Why is that? Because you don't have the capacity to deal with all of this, or the machine doesn't have the capacity to deal with all of this. Similar for you, that you don't have the capacity to deal with all of these different apps spread across, all right, and then you want to somehow consult by chunk your apps, right? So, well, now this is true for iteration and generators, and the other is now promise. They talk about also is the async generator here, all right. In describing it is behaviors. We're not going to talk about the behaviors in this model, okay. But I do think that this is quite important to understand this, digging into the roots, and also the reflection, which is something that it didn't we didn't talk about this, okay. The reflect object, the proxy object, as well as the model namespace objects here. And well, speaking of the memory model here, to understand more about this agents, event records, choosing values, abstract operation for the memory model, uh, relation of candidate execution, property of valid executions, race, data race, data race freedom. Uh, but again, more on that is on this topic here, on the control abstract operation, on the control abstract objects. Okay, the iterator, the generators, as well as the promise. Okay, and also some collections that we can have access to. So for example, like map, set, weak map, and weak set, and something known as the array buffer and things like that, which are, and also the JSON object, which are used more likely to, and this is something that we're gonna starting to use a lot, the array buffer objects and so on and so forth, uh, especially when we want to generate now random numbers. So in any case, okay. So now things starting to make a lot of sense. All right. So things starting to make a lot of sense. But in any case, this is the chapter 3. All right. In digging into the root of JavaScript, which is the iteration, uh, the entire concept of iteration. Why do we even care about the iteration? What is the problem that iteration solve? As I mentioned before. So you have now huge amount of records here, and then the question is, how do you now, well, consume each one of those record, not entirely, but but one chunk at a time, right? So what are the protocols, the mechanism, the no, the how to do stuff? So, well, as I mentioned, is in this particular uh, way, using now the iterator protocol, the iterator, the iterable interface, and also is how can we now is execute periodically. So by having now much more control of how can we now execute periodically is the control of a function. How can we now execute a function not until completion, but until a point that we want, right? So we can have now is this cooperative concurrency. And the other is now how can we deal is with eventual value that happen in our programs, and what are the protocols to do this. So for example, with promise. Uh, and another important topic is the properties that contains, or yeah, the characteristic of functions. So for example, with closures and the value of this, and also is the objects and the prototype link. So I think I make a case here to broadly describe now is the language, and understand finally and for once and for all is why do we even care about this language, and how can we now, for example, if you need to provide your service to a third party, how can we do all of this kind of stuff? Exactly. So how can we do all of this kind of stuff? So I do think that this is quite interesting for the technical aspect, and then I would like to move on to the more a product-like stuff. But at least right now is on doing this. So this is it, right? And so as a way to now understand is these different parts, all right? So like serving the JavaScript, or digging into the roots. First, we look at the scope, which is what we are doing right now here with scope, right? And as you can see, is get started scope here, right? So with scope, the idea is to, oops, well, you can, if you want to pay for that book, please be my guest. In my case, I don't have that amount of money to do so, but doesn't matter. I will in the future. But here is describing is what is a scope and why a scope is important to understand, because not only value is the most important part in any programming, but also working with variables is that how you can hold those values in a container is also too in any programming language, not in JavaScript, but in any programming language. This has also developed my curiosity in building is an app for iOS, right? Because I do think that is quite interesting to do that and to get into that point. Okay. So here we are, right? So here we are. So scope, right? So the idea of understanding now scope is because of understanding is first, why do we even care about this? Because we can use now scope as a way to organize our code, aka to make it much more readable. And in order to understand that, not only readable but maintainable for you from the future. So because now scope is is this mechanism, all right? So scope is now a well-defined rules. That's what a scope is. It's a well-defined rules. It's a well-defined rules. It's a well-defined rules to answer the question of how two variables with the same name, how does JavaScript exactly? So how does JavaScript handle variables with the same name? Okay, or how does JavaScript knows which variable can have access at that statement? All right, but a given statement. So we're talking about is now access and name resolution, and all of this is answered by scope, right? So in order to understand now scope, and because we might think that in JavaScript all programs runs from top to down, which is not accurate. In fact, JavaScript has now is a compile phase. In other words, is now you have a parsing phase that it analyzes your code before it is executed. So because the author decisions of where these variable or functions or blocks and how they relate each other are analyzed happen is at compile time. So the scope interesting. So I understand. I'm weaving the story here. Interesting. Makes a lot of sense. Okay. So the scope of this, right? Okay. Okay. Holy moly. So nothing is starting to make click here. Jesus. All right. Good. So because working with variables, one of the most important things that we need to know how to do in any programming language And in JavaScript, uh, we can hold values inside of those variables. And since JavaScript, uh, so we can we since JavaScript is a scripting language, we might think that this is now process our program from top to down, but the reality is that it has now a parsing phase before the code is executed. And the author decisions of where it puts the variable, the function, and the scope, and how they relate each other, okay, all of this are analyzing and ruled by the scope. So this scope, all right, which happens at this parsing phase. So the resulting analysis according to how now the functions, the variables, and blocks happens, and the result of this, which is the scope structure, is not affected by runtime conditions. So because now functions are values in our language, okay, and since those functions, we can define now variable inside of it, okay, and the scope structure is determined now at compile phase. We can now, whatever we want is run this code at different part in our programs while remaining the scope, and this is known as closure. So in order to understand that, we look now at what a compile and interpreter means, which is briefly described that this is the process and how the source text is going to convert into a human readable machine readable code, okay, and this now has two mechanisms of how to do that, right? We can do that as a compiling or interpreting. And the difference is that how they do that. In an interpreter language, you have to go line by line, all right, to detect and to execute that code. Whereas in a compiler, in a classic compiler theory, we have now three phases. We have first needs to transform each one of those words into meaningful token into the language, in this case for JavaScript, okay, similar like you do when you read now English. So once you understand a particular language, you're starting to identify each one of those specific tokens that are meaningful to that. But if you're starting to read now Arabic language or Chinese, okay, then you are lost. Okay, so this tokenization or lexing is that's what happened. So it's transforming is all of these different characters into meaningful tokens. And the word lexing is say, hey, as they describe here, oops, yes, as they describe here, tiki tiki, code generation like this. Yes, sorry, is the tokenization here. And the difference between tokenization and lexing is subtle and academic, but it centers on whether of those tokens are identified in a stateless or in a stateful way. So in other words, is to say, hey, if the tokenizer were to invoke stateful parsing rules to figuring out whether A should be considered a distinct token or just part of another token, that will be lexing. So in other words, is the tokenizer that when invoke the parsing rules to figuring out, hey, if that particular token is considered a distinct token or part of another token. and the other is the parsing. So once now the compilers transform all of these strings of tokens, is going to now create an internal structure to understand that the parsing, and create now this abstract syntax tree that now it contains the grammatical structure of the program. And then on the phase 3, which is code generation, you say, okay, now let me is to turn this into an executable code, right? In instructions that now the machine can understand. So JavaScript is this scripted language that it doesn't have any build step, so it needs to analyze these statements and execute that in microseconds or even less. All right, so that's why they rely on different of these hacks in the JavaScript implementations. So you have the just-in-time compilations and among other stuff. But the point of this is that because this is how now a compiled code works, and when we look at the JavaScript engines, the observable feature is how it process errors, particularly syntax errors, that it doesn't go line by line. In fact, it perform now is a syntax error check first, also early error check first, right? And another is the scoping here, or the hosting as well. So because this now makes JavaScript like a two-phase in language, all right? It has a lot of relationship. It has a lot of relationship of how now the language in itself act as a compiler language, not by its way of how the end file is distributed, but by how the code is analyzed. So I do think that it is very revealing here on how we can do this, because you can take a look. You can not take my word for granted. So do not take my word for granted. Check out the spec and see for yourself how the thing is actually working. All right. So that's pretty interesting stuff, at least to understand once and for all. And another thing is that this particularly concept of the the source and the source reference and the target reference, especially when you assign something to a variable, right? So because this variable assignments that can happen is in a var, or in a function declaration, or inside of a for, or even now when you is execute a function and assign it its value. So all of these assignments here is as a way to understand what these assignments are doing, whether it's this is a assignment target, if this is statement is an assignment target, or if this is now a source of an assignment. Okay, is just to now look at how, when we understand this reference here, okay, when we understand this reference here, we can now, which is something we're going to see, that what is the relevant topic of understand this source or target assignments and the sort of assignments. Okay, and we also look at cheating with runtime modification, which is bad idea to use eval here. And now that we show that because the scope is analyzed at interesting, because the scope is analyzed before the code is executing, known as lexical scope, and we understand is the lexing stage compilation. So to understand a little bit more and to have now a useful conclusion, so the key idea of the lexical scope is that it's entirely controlled by how we place. Okay, is the lexical scope is entirely control of how do we place the functions, the variables, and the blocks in relate to each other. Okay, so if we place now, exactly, the lexical scope is now determined or is associated. Okay, is controlled by how we put now functions. By how, by where, in this case there is here. So by where we put now functions, blocks, and variables in relate to each other. So if you put, of course, a variable inside of a function, you're gonna parse that into that variable statements as part of the scope of this function, right? And furthermore, is the referent of the source and the target and the source of an assignment, like this. A reference, target, or source for a variable must be resolved as coming from one of these scope. So in order to understand how these variables so in order to understand how these variables okay, okay, all right, okay, okay. So in order to understand now, yes, makes a lot of sense. This makes a lot of sense. So just to close the case here, vastly, bro, vastly, is to say, hey, we looked at the scopes are analyzed before the code is executed. This is known as lexical scope, and it is known as lexing because the tokenizer is determined whether is the parsing is stateful or stateless. In other words, whether if this particular tokens belongs to is a different token or is part of another token. Okay, so this decision is that when we look also at the place where we can put our functions, variable, and a scope in relate to each other, this is something that is controlled by the scope, by this lexing, by this tokenizer or this process. Holy hell. Oh my god. So this is now controlled by that. Makes a lot of sense. Okay, makes a lot of sense. Makes a ton of sense here. Okay. So if you need to explain briefly to somebody that doesn't know that, right? Why they call lexing here? Why this is called lexical scope? Just to make a quick recap here, in classic compiler theory, which is how you transform your source text, okay, into machine readable code, all right, there is a process, there is a machines that need to process that kind of stuff, And these machines, knows a compiler or an interpreter, all right, they do things different. So the only difference is in the way of how they generate this code here, okay, this binary code. So interpretate, what it does is to analyze statement one line at a time, pretty much like you're trying to translate or to try to understand this new jargon from kids, okay? And then you try to process each one of their statement that they're and what they mean, okay? Or if you're learning a particular another language, in, for example, Spanish or Portuguese, and then you starting to hear and you say, oh, okay, no, give me this statement, I know what it means, give me another statement, and so on and so forth, especially when you have in one-on-one person conversations. So this is interpretation. And the other is the compilation, right? It's like they already give you now is a full declaration written, okay? And then what you're gonna do is to take all of these particularly words, okay, and try to make sense of what they means to, right? So because because the compiler is now made of three different phases. One of them is the lexing. You can think of this like three peoples that live inside of these machines. The tokenizer, people, the tokenizer worker, the parsing working, and the generator, code generator worker. So the first, it say, hey, I'm going to take all of these different words from this text, and I'm gonna make them, and I'm gonna create tokens that are meaning for the language. Okay, and doing this tokenization or lexing, which is to determine which one of these particular tokens, if they belong to another token or if this is a different token. Because this decision that this parsing phase, that this tokenizer and lexing individual is doing, okay, and we also have is the once all of that token has been created, it's going to pass that to the parsing worker. It takes all of that and it's going to construct this it's going to construct this structure known as the abstract syntax tree. So you can think of this like a particular person putting all of these different boxes here and there to understand what all of these tokens means, right? And then it's gonna pass that to the code generation work, would say, hey, all right, I know this is the structure. Let me now is, well, generate is the proper machine instructions to now and optimize instructions, of course, to actually do so to generate this code that now the machines can understand. So because this process of a compile on the lexing, holy hell, it's quite it's quite verbose here. It's quite verbose, but I'm trying to make it small as possible here. When you need to try to explain what lexing mean, okay? Lexing means that where it was written. and all of this, yeah, where it was written. Where it was written. That's why people say, hey, no, this is mean that where it was written. But it turns out that the relationship by the observable reality here. So the relationship of how do we define is functions, variables, and block relate to each other's. These are controlled by this lexical scope at this phase on the compilation. And also is that because we can define now functions, because we can define is now variables inside of a functions, okay? And also, yeah, so by defining this variable inside of a function here, is now declaring that at that particular current scope, and when the and it's important to understand that this compilation doesn't actually do anything to reserve a space in memory. Instead, they compilate exactly. So, in order to resolve this reference, whether it's the source or the target, it's going to look at that particular in scope, and if it doesn't exist, it's going to look out of the scope until it reached to the until a matching variable declaration can be found, or the global scope is reached and there is nowhere else to go. And it is important to know that the compilation doesn't actually do anything in terms of reserving memory in space. Instead, compilation creates a maps of all the lexical scope that lays out of this. So in order to now understand or illustrate the lexical scope in here, I do find quite relevant to just briefly mention this particular metaphors. So one of them is how now we define is the to which variables this particular to which variable this particular scope belongs, okay? Yeah. To which variable this particular scope belongs. This makes a lot of sense. Absolutely, absolutely. So to which particular variable this scope belongs, so that's one, makes a ton of sense. Absolutely, absolutely. Um, mhm. Mm-hmm. So the idea here of illustrating is the lexical scope, but what that happen is that first is the association of these variables to which scope is the association of a variable association is a variable to an scope, okay, and the other is how this process happens, or exactly. It's describing is the association of this variable. It's describing the association of a variable to which scope. Okay, so it's the association of this variable to which scope. Okay, and also is that how this association happens, which is this particular conversation between these three individuals that live inside of the engine. One of them is the compilation, and the other is the execution. And during the compilation is going to determine is during the parsing is going to determine is the reference. Okay. Or it's going to determine is the identifiers. Exactly. So the name of this, and then at the engine time or the runtime time is going to determine is the reference here. One of them is the identifier, and the other is the um the the assignment of a reference here. That's what we look at, the target and the reference, and it's because this conversation that happens here. Interesting. Is this conversation that happens here uh, with that? Okay. So it's a conversation that can happen here. Interesting. Very, very, very interesting here. Mm-hmm. 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 Okay. Mm-hmm. Mm-hmm. So the reason why we look at this source and target reference is to identify now is uh, these conversations that happen when it comes to determining is at which variable this scope belongs. Since this is a conversation that the metaphor is that it's a conversation that happens between the uh, yeah, this is a metaphor this is a metaphor that happens. So all of this. So I am looking here at the. So yeah. So yeah. So yeah. So I'm looking here at the source and target reference, and why that actually matters, and it's because when it comes to determine the variables, uh, when it comes to determine at which scope these variables belongs, by looking at a particular metaphor with marbles and buckets, where marbles are the variables and the buckets are the functions or the block. Okay. Uh, and to illustrate how this association happens, we use a metaphor that happens between three individuals inside of our engine: the compiler, the scope manager, and the engine. So first, the compiler and the scope manager, what it does is to understand the reference, or understand is the identifier. The terming is the identifiers, and creates now and create now that identifier in that scope to map this. Okay, so once that happens, once it now the compiler and the scope manager actually create this map of identifiers, okay, at runtime, the engine now is going to ask the engine will going to ask to the compiler, to the scope manager, to say, hey, do we have this reference, because I need to assign this value to this, and this assignment is when that happens here. And also is the nested scope. So the nested scope also happens is because it has now this particularly reference that points that each one of those block has when it's created at runtime, and it points now to the outer and closing scope. And if one of these lookup failed, we're gonna say, hey, this is a reference errors. Hey, this is not defined. Exactly, a reference error. Hey, this is not defined. This is a reference error. Hey, this is not defined. And also you can is define it with the global scope via this. So I'm gonna make a quick pause here. And we're back with a different look. But this is what I want to explore here, you know? And now that I know why it means that, and when you need to explain that the parsing and the execution phase is all about that. You know, it's all about that. And let's going to continue the conversation here with the scope change. But it's that. So there is now, in order to resolve the variables reference at which scope they belong, it happens is at parsing phase and an execution phase. And then the parsing phase is when the compiler and the scope manager have a conversation, so to speaking. So then they say, hey, do you have scope manager? I have now this identifier. Do you have it? No, let me create that. And so on and so forth. And then at the execution time, the engine and the scope manager is when they have this conversation and say, hey, scope manager, I have this assignments to this identifier. Have you ever heard about it? And so on and so forth. But this lookup is more conceptual. Okay. I do think that that'll be all for this video. Take care. Bye-bye.